Hello guys, welcome back. Today we will again have some very good problems from the Allen score test series. So basically this is the first question, and before beginning with this video I would like to also share something important that I saw the poll. If you haven't voted the poll till guys, you can go to my posts section and then you will see there is a poll I have given on what type of content I should give. So basically I saw that some people, although majority of you are telling that outside questions and like other questions which are outside PYQs, they are good, but some percentage of you guys also said that I should include PYQs. So that's why I was thinking that this video will contain only Allen score questions, but on from the next video I was also thinking that I would punch some previous year JEE advanced questions as well. And if you guys also recommend, you can write out to me in the comment section if you guys recommend also, because I hope you are aware that JEE mains is also like the level of JEE mains is day by day getting closer to JEE advanced, so it is nothing different. So what I can do is I will not like solve many questions from JEE mains, although actually if we see like for example 2025, all questions which came were actually pretty good. Like it's sort of you have to find out very easy questions from difficult questions. That is what JEE mains paper was somewhat like this year. Anyways, so what I was thinking, I could bring in JEE mains questions also, like the good ones which are challenging. So if you guys want that, you can always write out to me. Okay, so anyways, I will now start off. You can try out the question by pausing the video, so I will wait for a few seconds. Okay, so I'm starting off now. So basically here we have a function defined on -3 to 3, which is given by function of x equal to 4x cubed minus 2x plus 1. And there is a function g of x which is defined something like this: f of x minus f of minus x by modulus x plus 2. So I guess this is actually a very pretty easy question. What I will do is I will first try to write it out g of x. So this is f of x minus of f of minus x divided by mod x plus 2, right? Now let's manipulate f of x minus f of minus x. So if you guys notice, like f of minus x, it will actually come out to be minus 4x cubed plus 2x, and plus 1 is remaining the same. So if we actually subtract f of x from f of minus x, plus 1 and minus 1 will get cancelled. Rest of it is actually remaining, I guess. Like this thing will become 4x cube minus 2x minus of minus. So plus 4x cube again minus 2x. So this is 2 times of 4x cubed minus 2x. And this is whole divided by your modulus x plus 2. So this is g of x. Now what I will do is, because if we take a look at the integral, this is minus 3 to 3 g of x dx. Now because this is minus 3 to 3, I guess we could take a chance by checking on what sort of symmetry actually the curve is having on both sides of the y-axis. Let's see that. So for that, basically I will find out g of minus x. So if we find g of minus x, this comes out to be f of minus x minus f of minus x. So f of x divided by, if we take minus x inside mod, that becomes the same. So basically if you see, I also actually there was no requirement to calculate this thing, although I did. But if you see that these two things are actually just negative of each other. Basically from here we can conclude g of x is minus g of minus x, which means that this thing is an odd function, right? And as you guys know, if we like say, if we try to draw an arbitrary graph of g of x, which is an odd function, it will always be something like this. Like on both sides it will be symmetric, but the areas, one will be above x-axis, other will be below x-axis. And that is why if this is a and this is also a, when we add these two up, they get subtracted and the net result is 0. So basically that's what we are doing. So this is actually an area of an odd function which comes out to be 0. So your answer for this question is 0. This is pretty simple actually, maybe the most simple question in this entire paper. Anyways, I will move on to the next question now. So here's our next question for the day. Now I don't know why they have given this question, because this question is like not even JEE level, right? This is so easy that you can solve it mentally also. I don't know why they have given this question, but anyways. I'm not waiting, okay, because this question is something that most of you will just in the short of click of a second you can do this question. Because as we can see that we have a function f of x which is given as e power frac of x. And as we all know that frac of x is ranged in between 0 and 1 always, right? So if we put e powers on both sides, so this is 1 less than equal to e power frac of x less than e, or we can write 1 less than equal to f of x less than e. Basically f of x lies in between 1 to 2.3. So we have to find the number of integers in the range of f of x. So basically we have two integers, 1 and 2, so your answer is 2. This took no short than about, I don't know, although I wrote all these steps because I'm solving it. But still, you don't have to like solve also. This is very easy, right? Like I don't know why they have given such an easy question. Anyways, we will move on to the next question. The next one will be interesting. So here's our next question, guys. Now this particular question, I would give this a double star. You can, like, if you are writing, you can give this question a double star mark. This question is like made very beautifully because this question, if you like see, because whatever like in during our practice when we get such questions with summation of sine inverse or summation of cos inverse, these are regularly asked, right? And you have also seen in PYQs. So such questions you will like go with the normal trigonometric approach to solve. That's right. We also can go for trigonometric approach, but what I will do is I will do the trigonometric approach for this particular thing. But in my opinion, actually this question can be solved using vectors. Okay, that can be an alternative way to solve this question, and it won't like cost you much of calculation, and your probability of making mistakes will also be very less. Now an obvious question in your mind can be that how can we solve this using vectors, right? Like there is nothing, no sign of any vector or anything, so that I will show obviously. And what I am doing is first you can try out this question if you want, like although I said vectors approach, if you want like have something in your mind you can do it with vectors, otherwise you can try out in the normal trigonometric approach. That is going to be a bit long, and then I am pausing for a few seconds. After that I will solve this question using both trigonometric approach as well as with the vector approach. So I am pausing for a few seconds. Okay, so let's start off now. So basically this question I am solving this first using the trigonometric approach. Okay, so let's write down first. This is your sigma I equal to 0 to n minus 1. Arc sine, wherever, like if you guys see anywhere, I hope you guys know this, arc sine actually means sine inverse. Similarly, if you say arc cos, arc tan, it all means inverse. Okay, it's actually like I don't know, sort of I guess American style of writing, but yeah, both are same. And within the parenthesis we have I into I plus 1 n squared, sorry, plus n squared, divided by root under I square plus n square into root under I plus 1 whole square plus n squared. This is something, and we have to solve this and get this whatever 2n minus 1 pi by lambda. So now what I will do is basically let's try to convert this into a trigonometric form, right? So what I will do is, now you guys after doing this step you guys will ask me like how did I do this, right? Basically, as you can see, if we divide this thing with n square, we will have I squared by n square under the root, and also this thing with n square, so I plus 1 whole square by n square under the root. So what I will do is, because we have I square by n square here and I plus 1 whole square by n square here, I am taking tan of alpha as I by n and tan of beta as I plus 1 by n. Okay, you will realize soon why. Now if we observe the numerator, it is I into I plus 1 plus n square. So if I take I am only writing the numerator right now. So if we take, this is the numerator. If we take n square common out, this thing will actually become I by n into I plus 1 by n. Like I divided n to both the fractions, and this is your plus 1. So basically we can write this as n squared tan alpha, and this thing will be tan of beta plus 1. And now if we look at the denominator, we can write the denominator as I said, we will take n square out. Basically we are like you can also say we are multiplying n square, or rather dividing n square to, we are dividing both numerator and denominator with n square, or you can say we are taking n square common out from both numerator and denominator, and eventually they are getting cancelled, whatever you are comfortable with. So basically this thing comes out to be I by n whole square. This is your denominator, and this is your plus 1, sorry, this is plus 1, and this thing is your root under I plus 1 by n whole squared plus 1. So if we observe carefully, like we can actually write this to be n square, and now this is your I by n whole square plus 1. So tan 1 plus tan square alpha, which is root under secant square alpha, so n square secant alpha and secant beta, right? So now let's rewrite the expression in a beautiful way. So now if we like, I am not writing that sine inverse that thing, I am leaving it and writing the thing only within the like brackets, okay? So this thing becomes n square tan alpha tan beta, and there was a bracket here plus 1, and whole divided by, we have here n square secant alpha secant beta. Now this and this get cancelled, and now if we write tan alpha tan beta sin alpha sin beta whole divided by cos alpha cos beta, so this thing becomes, I guess, sin alpha sin beta plus cos alpha cos beta. And now if we take this thing to the top, this thing becomes secant, I mean cos alpha cos beta, and one cos alpha cos beta comes down from here, both of them get cancelled. So this is what we have finally, and this thing is nothing but your cos of alpha minus beta. Basically if we try to look, our final expression actually becomes that big thing which we had. It actually becomes sine inverse of cos of alpha minus beta. This is what we have, and now what we can do is we can write this thing as pi by 2 minus cos inverse of cos alpha minus beta. So this becomes alpha minus beta. So basically manipulation is still not over, okay? We have to like further put on the values of tan and solve this. So let's do that. Okay guys, what I did was I actually missed out this pi by 2 here. So this is your pi by 2 minus of alpha minus beta. Please put this in a bracket, okay? Don't like write minus alpha minus beta directly. It's in a bracket. So now as we knew that tan alpha is your I by n and tan beta is your I plus 1 by n, I guess. So let's manipulate this a bit, okay? Okay guys, before proceeding, I would like to share an observation that I saw right now. Basically I am going back to the initial expression, okay, which was this thing, or sine inverse of I into I plus 1 plus n squared whole divided by your root under I square plus n square into root under I plus 1 whole square plus n square. Now you can go with this method if you want, but I found out something which can actually give us the result directly from here itself. Like you need to have very good manipulative skills and very good eyes also to see this, because most people won't see this here, okay? What I will basically do is I am rearranging this a bit. I will rearrange and write this as 1 plus I by n, and this is your I plus 1 by n whole divided by root under 1 plus I square by n square and root under 1 plus I plus 1 by n whole square. Basically the same thing that we wrote there, okay? Now what you will actually observe is, I will tell you that we can actually write this thing as sine inverse of, please like watch this carefully, this is very important, sine inverse of cos of tan inverse I plus 1 by n minus tan inverse I by n. Reason being, if you manipulate this inner part, I will do that, tan a minus tan b, right? So this will come out to be, sorry, tan inverse a minus tan inverse b. So this will come out to be n into 1 plus I minus ni whole divided by n square plus I into I plus 1. Now if we do like ni will get cancelled here. So if we do the cancellations, we will basically have n whole divided by n square plus I into I plus 1. Right. So now this actually will, like, if we simplify this thing, this will actually simplify to, I will change the page. This thing will actually simplify to pi by 2 minus tan inverse I plus 1 by n minus tan inverse I by n. What I would recommend is better to go with this second method, okay? The first method was a bit clumsy. I also felt it was a bit clumsy. So second method was actually better. Because this question is itself like, it's actually not meant to be solved like this. It's actually, it was given to be solved using vectors. The people there who made the question paper, in mind they had the purpose that the students who see this question, they will encounter this using vectors only, right? Although we are trying to solve, but anyways, it is solvable. I have solved it. So let's proceed now. So what I will do is, we have the final result, and please also don't forget we had a sigma before this, which I had not written all this time, but there was a sigma. So basically this thing will become n pi by 2. And nonetheless, I'm not telling this, like tan, if you put sigma here, first term will become tan inverse 0. Second term, no, sorry, first term will become your tan inverse of, I guess, 1 by n minus tan inverse of 0, and then on again it will continue. So basically some terms are getting cancelled, and final evaluation, this will actually come out to be tan inverse 1 minus tan inverse 0 all itself. Because when n minus 1 plus 1 is put here, this will be tan inverse 1, right? And n minus 1 by n will actually get cancelled with the term that, with, like, there are pairs basically. So if we put n minus 1 by n here, the pair which is present before this, the plus term in that pair and the minus term in this pair are getting cancelled. So I'm not doing that. Pretty easy manipulation. So basically if we now write this, this is becoming n pi by 2 minus pi by 4. And now for our desired form, if we take like the LCM, this is becoming 2n pi minus pi by 4. So your 2n minus 1 times pi by 4. This was our desired question. So lambda is basically 4. So now this was the trigonometric method for this sum, which was, I guess, pretty tedious, and, like, you know, whatever amount of questions you have practiced, I myself am saying that this method to come in the exam hall, this will take you a lot of time. This was a, like, if there was no alternative process actually present to this particular question, then this would be a god level question on inverse trigonometric series. These sums are basically inverse trigonometric series, and in between there is a telescopic series which is stuck. So yeah, this will be a god level question if this thing is present, but we have an alternative process to do it with vectors. So now I will do that process and you will realize that it is much easier. Let's go on to that. So basically what I will do is, I'm defining something, like I'm writing define for, let's say we take I as a variable from I equal to 0, 1, 2 up till n. Let's have some vectors vi, sorry, bracket it's not here, vi, which is equivalent to I comma n. Okay, it's basically I cap plus n j cap. I wrote it in a coordinate form. Okay, now obvious question is why I did this, so you will realize. So I will try to draw a rough diagram. Let's draw a rough diagram. This is your first vector, and say this is your last vector, and now we will have many vectors stuck in between these, and this will go on like this. Somewhere here we will have the second last vector. So let's try to write out. This is your 0 comma n. This is, you can say this is your y and x axis. This is your 1 comma n. This is your 2 comma n. this is your 3 comma n, and this thing will be n minus 1 comma n, and similarly the last one n comma n. And let's say they make some particular angle, right? So let's say this is theta 1, this is theta 2, this is theta 3, and this goes on like this, and let's say the final angle is some theta n. So let's define theta also, because we will need it. So let's take theta I plus 1 to be the angle in between, like this and this, right? So Vi and Vi plus 1, between Vi and Vi plus 1. Let's define something like this. Now if you guys observe carefully from here, we can actually write something, and that is I into I plus 1 plus n square equivalent to Vi into Vi plus 1. Basically this is nothing new. We took the dot product of the two vectors, and this is what we will have. Like if I want to explain this like elaborately, you can say one vector is I comma n, another vector is I plus 1 comma n. So if we take the dot product, this is what you will have. I guess this was pretty obvious. So now I will try to manipulate this somewhat. Okay, this Vi and Vi plus 1. So basically we are taking the dot product, and dot product, as you know, it is modulus of the two vectors multiplied and also multiplied by the cos of the angle in between them. So that will become root under I square plus n square into root under I plus 1 whole square plus n square, and this thing is your cosine of theta I plus 1. This is the actual expression for the dot product. So if we like now take cosine theta I plus 1 and write all the other terms in terms of it, this will become I into I plus 1 plus n square whole divided by root under I square plus n square and root under I plus 1 whole square plus n square. And that is where you will realize, like, shocking discovery, that this thing and the term we had in between, that big sigma sign, are actually the same. So that's why I said that vectors are actually useful, right? Basically you solved an inverse trigonometry question using vectors. So yeah, you can, like, this is a very beautiful question. God knows how they have framed it, but absolute JEE advanced, core JEE advanced level. Anyways, so now we have this thing ready, and theta I plus 1 will basically become cos inverse of this. I'm writing it like this. Theta I plus 1 will basically become cos inverse of this huge thing. So now we need sine inverse of this huge thing. So basically pi by 2 minus cos inverse. So let's do that. So we need the sine inverse, also sigma, from I equal to 0 to n minus 1 of this thing. So it's basically your pi by 2 minus cos inverse of your this huge thing, and also the, I forgot to write the sigma. So now I guess also another observation that I would like to make, because we will need it here. If you observe carefully, I will go on to the diagram once. Basically, if you observe, if you sum all of these angles, right, you will actually get pi by 4. I'm explaining how. You will get pi by 4. Basically, because this is will like some sort of come into a series, you will put theta 0 plus, I'm sorry, not theta 0, theta 1 plus theta 2 and dot 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 up till theta n minus 1. If you guys like manipulate this sigma, you can actually find out, or what you can do is, if you take this huge angle to be theta, that is actually the sigma, you can take the dot product of the final and the initial vector, then also you will find it will come to be 1. Okay, like, yeah. So I guess now it's pretty clear, and so we will use this result in our question now. So let's write it down once for our reference. This is n minus 1 theta I plus 1, this comes out to be your pi by 4. So now if we sum this particular thing, actually if you see the summation part, what we had there in the trigonometry process and what we have here in this vector process, actually this thing is coming out to be almost same. Pi by 2 minus theta times I plus 1, which is your pi by 4. Nonetheless, this thing will become your n pi by 2. Okay, and this is your sigma. Okay, sigma equal to 0 n minus 1. Basically, I guess I should write these two separately. This will become clumsy otherwise. Yeah. Like, don't think that we have two sigmas one after the other. Don't confuse. Okay, these are two separate. So n pi by 2 minus pi by 4. This is the result we actually had in the above process. So once again, your answer is 2n minus 1 pi by 4. So lambda is 4. And this is how we solved this question using inverse trigonometry as well as using vectors. This question was beautifully framed, like very, very good question. Okay. Like you can give this, if you want to rate this question, a 5 out of 5. This was a very good question. And if like this was asked maybe in JEE Advanced, people will always try to run after the first method I did. And you guys also saw how complicated it was. Okay. Because like seeing the solution, you guys might think that I will do this in the exam hall, but actually practical thing is if you go into the exam hall, seeing the solution makes it pretty easy that I can understand this. But coming these things coming to your mind is a very rare case, even for very good students. Okay. So basically this method will be your lifesaver. And now you should have those things in mind, that how dot product works and all, because it's like you are in this vector method solution, you are like framing a whole new question out of it, right? Like that. Like I took some considerations, I let theta I plus 1, I defined something, some term I defined vectors vi. So those things, it's like framing a whole question. That's why those things actually make this question out of the box. Anyways, I hope you guys like this question, and this was pretty tedious. So if you have any doubts, you can ask me in the comment section. Okay. So let's go on to the next question. So here's our next question. So not like the level is not like the last one, but this question is also a very goated question. Very good question. You will see, I will give you a small hint. You will also see uses of properties of triangles in this particular question. Although you can see tetrahedron and you will wonder how, but properties of triangles will be required to some extent. Okay. So you can try it out, guys. I will wait for a few seconds. Okay, so I'm starting off now. So basically we have ABCD, which is a regular tetrahedron. So first let's construct that. So I am doing this like I am drawing a tetrahedron in 2D. So this might look like a rhombus with its diagonals extended, but please, it's a tetrahedron. Okay, many of you like have this confusion. It might look like that, but it's a tetrahedron. So, and we have some more data given, that we have points x, y, z lying on the rays AB, AC and AD. So let's mark the points first. This is say your x, and I'm taking it to be small x vector. I am taking this to be your small y vector and this to be your small z vector. And we are joining these points like this. And let's mark also. We have x on the ray AB, we have y on the ray AC and z on the ray AD. This is roughly your diagram. And I will also write out that modulus x vector is your capital X, modulus y vector is your capital Y, or rather let's take it to be small x and small y only, otherwise it will become clumsy. And let's take modulus of z vector equal to small z. Now we will do a few quick observations. If you notice carefully, if we observe the angle XAY, if we try to observe the angle YAZ and also the angle ZAX, basically this is like nothing, it's wrong to say observe, it's an obvious property, all of these will be 60-degree, right? Now why I mentioned this exclusively, because now we will be using cosine rule here. So I hope you guys know about cosine rule. If you guys don't know about cosine rule, then like I can give you a short introduction about that. Cosine rule is basically, say, okay, I'm writing it out for one triangle. What I am doing is I am writing it out in this symbolic form, so you guys will understand how it works. Okay, if you don't know. So say if we try to write out cosine rule for the triangle AXY, so that will actually become xy squared equivalent to ax square plus ay square minus of these two sides 2axay and the included angle between them, which is cos 60. This is basically almost like the vector addition of two products. Okay, very similar, but not exactly similar, but very similar. So now we have to do some sort of manipulation. So if we try to write out, this thing will actually become, and we have some information also given, that xy equal to yz equal to 7 and xz equal to 5. We will use this and write out the equations. So first equation becomes 49 equals small x squared, the modulus of these vectors, plus small y square minus xy. Let's name this equation number 1. Next equation becomes 49 equals y square plus z square minus, I guess, yz. This is your equation number 2. And the third one becomes 25 equals z square plus x square minus xz, equation number 3. And now we'll do some manipulation with these equations. Let's do that. So first what I will do is I will subtract equation 1 from equation number 2. Okay, I'm writing out the steps so that you understand. This thing actually becomes x square minus z square minus xy and plus yz equals to 0. So if we take common, I guess pretty simple, x minus z into your x minus y plus z equal to 0. So now these two vectors can't be equal, pretty obvious. So from here we will have y equal to x plus z as our first requisite condition. Let's say, okay, what I will do is now I will take this equation and now I will put this value into this equation. Okay, like, okay, not the second one, sorry, it's not the second one. Okay, I will write it down. I am taking equation number 1 and satisfying this. Okay, so this thing becomes 49 equals x square plus z square plus xz, and also I will satisfy this into your equation number 3. So this thing becomes 25 equals x square plus z square minus xz. Let's name these as 4 and 5. So now let's add up 4 and 5. I will do that. So basically if we add, this thing becomes actually 74 equals 2 times x squared plus z squared. So x squared plus z squared is your 37. And we also need another condition to get the values of x and z. So what I will do is I will subtract equation number 4 minus equation number 5. And if you guys observe carefully, it will be 2xz equals your, I guess, 24. So from here again we get, after subtracting, xz as 12. Now we can put this thing into this and solve. So okay, rather than solving this quadratic, I can also apply another trick. Let's do that. What I will do is I will write x square plus z square as 37. Okay, and now I am taking the values of x plus z and x minus z whole square. So x plus z whole square is your, basically, because calculation will be simpler than solving a quadratic with those big roots and all. Okay, x square plus z square plus 2xz, I guess this comes out to be 37 plus 24, so 61. And your x minus z whole square will be x square plus z square minus 2xz, which comes out to be, I guess, 13. So x plus z is your root 61 and x minus z is your root 13. So let's add these two up, and I guess 2x will be root 61 plus root 13. So x comes out to be root 61 plus root 13 by 2, and y comes out to be, I mean, sorry, not y, z comes out to be root 61 minus root 13 by 2. Now I guess what I should say, this is the both the saddest part of this question as well as annoying. You actually won't ever need x and z. Okay, you found x and z just to find out y, and there is no other alternative. You can't, like, you will never get y if you, from this equation you will never get y if you don't know x and z. So that's it. Basically, that's why I averted this thing, calculating the quadratic, because you can see this calculation is much more simpler, and if you have like you are fast in solving, then this particular thing will take lesser time. So now let's find out y, which is equal to x plus z. So y becomes x plus z, root 13 cancelled, and 2 root 61 by 2, so root 61. Basically our y becomes root 61. And now we have to find out the volume of the tetrahedron. Okay, now volume of tetrahedron is nothing but this thing, right? 1/6 of the, you can say box product, or you can say scalar triple product, whatever you want. So basically now if we open this up, we can write this as 1 by x, x, y, z. These are the mods. Okay, that's why I took it above as small x, small y, small z only. And this is root under of 1 minus 3 cos square 60 plus 2 cos cube 60. Yeah. So now an obvious question can be that where this big expression came from, right? So if you guys like, nothing to explain, because if you guys have read about coterminous edges, right? In tetrahedron, if you read about coterminous edges, 60-degree was the angle in between the coterminous edges. And so after that, basically, if you manipulate that scalar triple product, you will get this thing. I'm not doing that. Like it's x dot y cross z, right? So if you manipulate that entire thing, and when you take the modulus, this is what the final result comes. This is not written in many books. I found, I don't know, like I have found this in 1 or 2 standard books, and that's why I remembered this can be your included angle. I've seen this in many standard examples and books also. Anyways, I hope this is understandable, and if you still don't understand, you can ask me for an explanation down in the comment section, and I will do that. So this thing becomes 1 by 6 and xyz root under 1 minus 3 by 4, because cos square 60, and this thing is your 1 by 4 because 1 by 8 into 2. So this thing becomes x, y, z, and I guess whole divided by this thing would come out to be half, so 6 root 2. So your v is x, y, z by 6 root 2. Now this thing is also actually a standard result. You can, if you want, you can remember this thing, okay? Instead of remembering this, you can actually remember this thing. Like in many usual cases, because coterminous edges, right? So 60 degrees is the general angle. Maybe in some specialized case, if they give you that, although it's not practically possible, otherwise geometrical figure will be, it will be, I guess, problem to form the tetrahedron. But anyways, if they give you some other case, then you can obviously use this. But I guess remembering this is a better option, because even if you guys look into such some solution in standard books, you will see this formula directly written. I have seen. So my advice, please remember this. So now I guess the sum is over. We can now find out v directly, which was asked to us. So v becomes 1 by 6 root 2, and this is xz is a plus b into a minus b, and also half half, so I take it as 1 by 4, and 61 minus 13, I guess this will come out to be 48, and your 48, yeah, right? Yeah, 48, and this thing is your root 61. So 12, this thing is 2, and now if we cancel this thing with root 2 and take this is root 2, and now if we take this 2 together, this will become root 122. Now I guess there was something sort of given volume, and we had to find out the square of that expression or variable. So v square is your 122. This is the final answer for this question. This was a fantastic question, like fantastic in the sense like not for this formula. If you look into this part where we manipulated all these equations, this is something which you should do pretty fast, okay? Like my personal advice, whenever you can get such type of questions have been asked previously also in JEE Advanced, where you like this is sort of unknown. You can get a set of equations where you have to manipulate and do everything. So you should be really fast in these parts, because this is where you should never waste your time, right? This is all simple basic stuff taught in class 8 and 9. Just you have to find out correctly, and yeah, you should know cosine formula. So practically properties of triangles is some chapter that many people do leave out. Although cosine rule and sine rule are also taught, I guess, in physics. But yeah, many people leave out properties of triangles. So don't go into that. Read properties of triangles, everything. Like I will give you questions on that also. Maybe we will have in the future papers circumcircle, incircle, properties regarding that, formulas regarding that. There are, I guess, 6 or 7 variations of formulas. Like you can say 6 or 7 formulas for the area of a triangle using different parameters. Except the Heron's formula, you know, and half into base into height, there are 5 more, right? Using different things like semi radius, they have in radius, some in circumradius, then the angles. So there are different things that is included in properties of triangles. And JEE Advanced, I guess last year 2024 they had asked a question where you would need to know the, I guess, in terms of circumcircle or incircle, I don't exactly remember, you should know the formula for the area of triangle. So if you don't know that, then your question actually goes wrong, because generally the places where they include these things are pretty simple. But if you don't know that part, you will actually regret later on. So please read that chapter, don't leave it, okay? So yeah, so I am moving on to the next question now. So here's our next question. Now, as we did pretty difficult question, so let's move on to a little bit medium side. So this is your question. We have to find out the number of solutions to this equation in the range minus 2 pi to 4 pi. So you can do that. I will wait. Okay, I am starting off. So basically in this question, what I will do is, let's take this f of x, like this huge expression, to be f of x equal to x cube plus x square plus 3x plus 2 sine x. Now let's find out f dash x. This is your 3x squared plus 2x plus 3 plus, I guess this will become 2 cosine x. Now I will rearrange this in a way so that we can actually determine the sign of this expression without problem. So I'm writing this thing as 3 times of x plus 1 by 3 whole squared. I hope you can understand by taking 3 out, and we will have like a minus 1 by 3, I guess, left out. So plus 2 cosine x and plus 3 minus 1 by 3, I guess 3 3s are 9 and minus 1, so 8 by 3. So I guess now it's pretty clear. This thing is obviously greater than or equal to 0 and minus 2 to 2. So in either case, this thing will always be positive, right? Because cosine, this 2 cosine x is minus 2 to 2. So in any way, this whole expression is positive, which actually means that our f of x, this part is a little bit manipulative, okay? Otherwise, you have to like do all sorts of, also you can determine from here also, but in my opinion, this thing was a good step to be done. So basically, clear conclusion that fx is very strictly increasing, and as you can notice, only at f of 0 equal to 0 there will be a solution. Like this will go on something like this. I'm drawing an approximate, like this was from minus 2 pi to 4 pi, right? This will never have any root in between, like except 0, no root. It will go on like this. Something of this sort. It will continuously go on increasing, okay? Strictly increasing. So yeah, our final option for this question is option D, where is one solution. This was pretty simple. Now let's move on to the last question for today. So here's our last question for the day, and please note this thing is actually hidden. It is y equal to ln or ln square x minus 1. So we have to find out the area enclosed by the graph of this function that is lying in the 4th quadrant. So I guess first thing is we have to find out some sort of information about where this graph is increasing and decreasing. So for that we will differentiate this one time as y dash. So this thing becomes 2 ln x by x, right? And now if we put this equal to 0, x obviously can't be 0, so x has to be 1. So if we put x greater than 1, then this thing becomes, say this is your ln square 4 minus 1. So I guess y is increasing here. And if we put 0 less x less 1, then obvious fact y will be decreasing. Because if you observe ln curve, or log x curve, it goes on something like this. So basically ln square will also somewhat act in a similar way, and also not in a similar way, like the increase or decrease will be, the rate of increase or decrease will be also greater, right? If I want to explain in terms of language, we can say the rate of increase or decrease of ln square x will be greater than ln x, something of that sort. So this is our roughly idea. And now let's find out the roots of this equation also. So ln square x minus 1 equals 0. So ln x is plus minus 1. So basically our x is 1 by e and e. And now if we want to find out only the area that is lying inside the fourth quadrant, then the area expression will be something like this. This is your a equal to integral 1 by e to e and ln square x minus 1 dx, and let's also put a mod in any case if something comes out to be negative. Okay, this is your expression. Now what I will do is, what an obvious question that you can ask is, how did I actually know that this thing is actually lying under the fourth quadrant, right? That is pretty obvious. So we will try to draw the graph for this because we have everything ready. So let's try to draw the graph. So when, I guess, if we tend y to positive infinity, I guess this thing is also tending to, I guess, something like this. Will come something like this. And this is the first point where it cuts, which is, I guess, 1 by e. It will go a bit down because 0 to 1 it is decreasing, right? And after that it will start increasing. Basically, if we see, actually the curve is this shape is actually not very correct. I will redraw it. The shape of this part. This is actually something of this sort. Yeah, now it is okay. Basically we will have 2 here, e is 2.3, so here, and like here where there is a horizontal tangent, this point is your 1. At this particular point there is a horizontal tangent. Okay, this is the graph of the actual curve. Somewhat it will, I guess it will look something exactly like this. So that's why the area between e and 1 by e is in between like in the fourth quadrant, and because this area is lying below the x-axis, and that is why I put a mod. All things cleared. So now let's go on to the solving. So now to solve this equation, what we will do is, minus 1 we can keep outside the integral, like not a constant, but this is something else. It will evaluate to, I guess, e minus 1 by e. Anyways, so ln square x now we can do by parts. Let's do that. So we can write this as your mod integral 1 by e to e ln square x, this is 1 by e dx, and minus of integral 1 by e to e dx. So now let's apply by parts to this. This thing becomes pretty simple by parts. I'm not explaining much. X ln square x from e to 1 by e minus integral 1 by e to e, and if we differentiate ln square x, this comes out to be 2 outside we keep, and ln x by x, and also multiplied by the x already present dx. So that's it, and now this and this get cancelled, and we have here minus integral 1 by e to e dx. So this thing becomes minus 2 times integral ln x, which is, I guess, pretty easy to evaluate. This thing is your x times ln x minus 1. If you guys don't remember this, please remember this as a standard result. This is your x times ln x minus 1. So I'm going for the final manipulation. Please do the calculation, guys. I'm finally manipulating this. This thing becomes minus 2 times x ln x from e to 1 by e, and your minus of this thing is your e minus 1 by e. Sorry, this is mod, and this comes out to be minus 2 times of, let's combine everything. This is your e, and I guess plus 1 by e, and minus of e minus minus plus 1 by e. So basically this and this get cancelled. So your final answer for this question is 4 by e. I will check the option once, which is the correct option. So as you can see, our correct option for this particular question is option number B. I guess this will be the final question for today. We did two very interesting questions today. They were very good questions, right? So I will try to bring on such further questions in my next videos. And what I will do is, if I feel convenient, like depending on what type of questions are appearing and what type of questions I'm selecting for each video, I will try to bring out relevant PYQs to them. Or if you guys want me to do a separate PYQ series only altogether, like only filled with PYQs chapter wise, you can also write it down in the comment section. I will do that also. So that's it for today, guys. I hope you liked the video, and if you liked it, do like, share and subscribe to my channel. So thanks for watching.